Lesson 4-3 on solving rational equations. As you can see, we have 5 steps listed here, and I'd like you guys to just take a moment and go ahead and pause the video so that you can copy these down, and then we are going to dive right into doing 2 examples. Okay, thank you for taking care of that. So let's look over these steps and then we'll go start example number 1. First step, just like we have in previous sections, I need you to look for any opportunity that you have to factor wherever possible. So whether you are factoring trinomials, looking for the greatest common factor, applying difference of squares, look for every opportunity you can to factor. Second step, you are to find the lowest common denominator, and we will use the letters LCD moving forward. Look for the lowest common denominator. Step number 3, we will talk about what exactly restrictions or excluded values are when it comes to solving rational equations, so stand by on that. Number 4, once you have determined the LCD and stated what the restrictions are, you are going to proceed with the beginning step of solving rational equations. So you will need to multiply each one of the terms by the lowest common denominator. And when you do that, you are only doing it to the numerator value, and you are going to realize that in the end, things are going to cancel out. In other words, reduce to 1. And lastly, in so doing, steps 1 through 4, it will lead you to our goal of solving for x. So, example number 1, let's start with that. Take a moment and copy down example number 1. Okay, so let's look at this problem and see if there's anywhere we can factor. So when I ask you guys to factor wherever possible, I want you to look at each term and each term's numerator and denominator and see if any of those values are able to be factored. And you will see in this particular problem, everything is pretty much raised to a power of 1. We don't see any opportunities to factor. So as far as step number 1, we are done with that. Now we're going to go look for our lowest common denominator. So I'm purposely going to be finding the LCD over here on the far right hand side. So this is more like side work, right? So my lowest common denominator is always going to be the list of the factors of your denominator. So the denominator in this problem, and in this term, is a 1. The denominator here is an x minus 1, and the denominator here is an x minus 1. So if I were just listing out side by side all the denominator factors, well, the only denominator factor mentioned in this particular problem is x minus 1. For instance, if I had this first x, this is me making up a completely different problem, and let's say it was x over x plus 3. The LCD then in this problem would be, whether you put the x plus 3 in the front or the back, it does not matter. X plus 3 times x minus 1 would be the LCD of this problem that I'm making up here, okay? So you list the factors, and you don't rewrite the factors more than once. So even though x minus 1 is mentioned twice here, you're just going to write it once when it comes to LCD. So let's return to our actual problem. So the LCD in our actual problem is just x minus 1. So that is step number 2. Step number 3 asks us to state the restrictions. Now, what exactly are the restrictions? Well, we want to avoid, we want to avoid at all costs, avoid our denominators becoming 0, okay? And the reason we want to avoid that is because it causes our fractions to become undefined, okay? We do not want fractions to become undefined. You cannot divide by a 0 value. So when I ask you to find restrictions, I'm asking you to exclude those values that would cause your denominator to become 0. So you are going to use what you found in the LCD, okay? So I'm going to do the work again, still working on the side. Take your LCD, every single one that you find, and you are going to tell yourself that you do not want that LCD to become 0 because it will cause your fraction to be undefined. You are going to solve for x, and in this case, I need to add 1 to both sides. And so my undefined value, my restricted value, my excluded value is going to be the positive 1 value. So x is not allowed to equal to 1. And you will find out in the next section when we start graphing rational functions what role those restricted, excluded values play. Okay? So now that I'm done with steps 2 and 3, so I'm going to just box this in here for a second. That's just some side work that I just will come back to eventually. So let's move on to step number 4. We are now going to multiply each term by the LCD. This term, and this term is going to be multiplied by the LCD. But notice that I said only the numerator, okay? So this equation right here that's written in white, I'm going to rewrite it, and anytime I multiply by the LCD, I'm going to write it by in yellow with x minus 1 so you can see and it stands out exactly what we're doing in step number 4. So here's what I'm saying. This x is like saying x over 1, right? Well, this x is a numerator value and it needs to be multiplied by the LCD x minus 1. So I'm writing x minus 1 right next to it. And after the x, there was a plus, and there is a 2x plus 5. And even though you don't see it, by the way, this 2x plus 5 actually has parentheses around it, okay? So whether you put them or not, that's up to you. But that 2x plus 5 is going to be multiplied by x minus 1. Again, because 2x plus 5 is in the numerator. And all this is over x minus 1. Equals, now we have 7 over x minus 1. My 7 is in the numerator. It also needs to be multiplied by x minus 1. And I need to bring down that other x minus 1. So each term was multiplied by an x minus 1 to the numerator value. And if you notice in step number 4, once you do that, you need to look for opportunities if you can cancel. Cancel like factors. So in this case, x minus 1 and x minus 1, let's choose a different color here. Let's use this bright green. There will be reduced to a 1. This x minus 1 and x minus 1 over here also would reduce to a 1. Okay, they cancel each other out. So I am going to write what remained. So this x times x minus 1 comes down. This plus 2x plus 5 comes down, equals, and this 7 comes down because everything else disappeared, okay? Literally, they just cancel out, erase them. Now I have a simple equation that I will just proceed in solving using all the skills of solving that I already know from past. So x times x is x squared, x times 1 is negative 1x, plus a 2x, plus a 5 equals a 7. Can I combine any like terms? I sure can. Negative 1 and a positive 2. So x squared plus 1x plus 5 equals to 7. Now I want you to notice, make a note over here, notice an x squared term exists. And when that happens, okay, and you are asked to solve an equation, you have to therefore set the equation equal to 0. so that you can solve, okay? And right now my problem is set equal to 7. So in order for it to be set equal to 0, I'm going to subtract 7. And once I do that, I will then be able to factor to solve for x's. So let's subtract 7 on both sides, and I have to subtract it with the 5 because I have to stick to like terms. My x squared comes down, my positive 1x comes down, or you could just write it as x, and my minus 2 comes down, and then it's equal to 0. So notice in this particular problem that my a in this problem is a 1. It's the coefficient of x squared. My b, the coefficient is also a 1, and my c is a -2. Now, when you are factoring a trinomial where a is equal to 1, we are pretty happy about that because once we figure out the answers to our little questioning rubric, that usually is what our factors are going to be. So what times what is equal to the c value of -2, and what plus what is equal to my b value of 1. So in this case, my answer is going to be what? Well, if you've already guessed it, it's going to be a +2 times a -1. Okay, a +2 and a -1. +2 times -1 is -2. +2 plus a -1 is a +1. So I can come over here, write down my +2 answer and my -1 answer. And indeed, if I were to multiply this out, I would end up with x squared plus 1x minus 2. Okay? And if you wanted to check, like I've shown you guys many times, FOIL it out. X squared, and then minus 1x plus 2x minus 2, and these two become x squared plus x minus 2. And that's exactly what we had originally. So anyway, back to our problem. Once you have factored, find your x values. You need to set the first factor equal to 0 and solve. I need to subtract 2 on this problem to isolate the x. So x is equal to -2. I'm going to box that answer. And then this one over here, I need to set x minus 1 equal to 0. I need to add 1 to both sides. So x equals +1. I'm going to box that answer. So you would think that that's all you need to do when you need to put that answer into Delta Math as your final answer. But here's what I need you to check. Always check if they are restricted. So you're going to look back at that side box that I wrote upstairs. And according to your restrictions from step number 3, x is not allowed to be a 1. And you boxed in a 1. So in this particular problem, you're going to have to remind yourself that, nope, I cannot put that as one of my answers. The only answer that I can put as a final answer is x equals -2. That one is allowed. The other one is an excluded value. This one's excluded, so do not put it in your answer. Okay? So let's do one more, and then you can continue with the work or get started on your work. Go ahead and copy down example number 2, and we will go through the steps. All right. 1 over x squared minus 6x plus 1 equals -4x over x minus 6. So step number 1, factor wherever possible. Look at each of your terms' numerators and denominators and look for opportunities to factor. And hopefully you are already eyeballing the x squared minus 6x, because especially that 2 sends us a signal of yes, this needs to be factored. And the factoring approach that you would take in this particular problem is the GCF. You will factor out an x, undistribute the x, and you are left with x minus 6. X times x is x squared, and x times 6 is 6x. The 1 is as simple as it can get. I'm going to put that negative with the 4x. You can choose where you want to put it, with the numerator or the denominator. I'm going to put it with the negative 4 upstairs, and that cannot be factored either, as well as the x minus 6. So we're done with step number 1. Step number 2, let us mimic what we did last time and just use yellow to write out our LCD. So LCD is the listing of all your denominator factors. Listing of all your denominator factors. So this is a denominator factor. This is a denominator factor. This is just an invisible one. It doesn't help. This is a denominator factor. I'm going to write them out without any repetition. So x and an x minus 6 are my LCD factors. So to find those restrictions, I am going to take each one of the factors that I found. In the previous example, we only had 1, but here we have 2 factors, okay? So I'm just going to put a little dividing line here. My x, I need to set it not equal to 0, and my other factor, x minus 6, I'm going to set it not equal to 0. Well, x not equal to 0, I can't do anything more with it. With this one, I need to add 6 on both sides, so I will get x cannot equal to positive 6. So those are my 2 restrictions. So when I finish this problem, if I get either one of these answers, I would know to make sure to not include them as a final answer, as a solution of my equation. So let's proceed now to step number 3. Step number 3 says take that LCD, so in this case x times x minus 6, and we are going to multiply each one of our numerators by that LCD. So let's start. I'm going to write down my little bar here. I'm going to write the 1, and I need to put the LCD right next to it, the x and the x minus 6, and write the remaining part of the problem. Okay, plus this one also has to have an x and an x minus 6 with it. And then I need to put an equals. And then I'm going to put a bar again and make it long enough so that I can include the LCD of x and x minus 6. So what's written in white is the original problem, and what's written in yellow is me doing step number 3 of multiplying each term's numerator by the LCD. And once you multiply by the LCD, you are going to look for the opportunities to cancel like factors. So in this case, these x divided by x, x minus 6 divided by x minus 6, x minus 6 divided by x minus 6, all of those reduce to 1. And now we are going to bring down everything that did not disappear or cancel out. So I'm left with a 1, a plus, a 1 times an x. I'm just going to write x times x minus 6. By the way, I just did this. 1 times x is just x equals a negative 4x. Then you are going to distribute, always get rid of those parentheses, by multiplying. So x squared minus 6x equals negative 4x times x, which I originally forgot. There we go. Sorry about that hesitation there. So let me clean that up, because negative 4x times x, let's just write it as negative 4x squared. Okay. So again, we notice that we have some x squared terms, right? And when you have x squared terms, we know that we need to set equal to 0. So I am going to move that negative 4x squared over to the other side so it adds with its other like term. Whoops. And that way, now my problem is going to be equal to 0. So positive x squared and 4x squared makes 5x squared. And now we have it equal to 0. Okay? Now, notice that our trinomial is not written in order, in standard form. So let's rearrange our terms. So it's written in ax squared plus bx plus c form. Okay. And let us identify the a as a 5, the b as a negative 6, and the c as a 1. So I want you to notice here, unlike example number 1, a is not equal to 1. So here, when that happens, I need you guys to remember that this is the one where you have to factor by grouping. And factor by grouping entails you converting the trinomial into a polynomial of 4 terms. The questioning technique that you need to remember is what times what is going to give me an AC value, AC meaning A times C. So 5 times 1 for our problem is a 5. And the second question remains the same as the previous example. What plus what gives me my middle term middle term coefficient, which is negative 6. For this particular problem, our answers are going to be what? That's correct. A negative 5 times a negative 1 satisfies both of these problems. Okay, so we're going to take these answers. I want you to notice that we are specifically saying that negative 5 plus negative 1 is negative 6. So I'm going to replace this term with negative 5 plus negative 1. So rewrite trinomial, rewrite trinomial as 4 terms so that we can do grouping. The first term of 5x squared comes down. The middle term of negative 6x is the one that I am going to convert into 2 terms. I'm going to convert it as negative 5x and negative 1x, which are the 2 numbers that I just found. Okay? And I do that because now I can just imagine myself dividing this polynomial in half so that I can factor by grouping. So I'm going to write this note over here on the side to remind you, you're going to factor by grouping and you're going to use GCF to do that. So what is the greatest common factor between 5x squared and 5x? Well, it's just a 5x. So 5x is pulled out, and what is left over? Well, if you divide both these terms by 5x, you get an x minus a 1. And then I'm going to bring down the middle sign, which is a minus, and the GCF between negative 1x and plus 1 is a 1, so minus 1. Divide both of these by negative 1, and you are left with x minus a 1. Okay? And we are relieved to see that this factor and this factor match. That's part of the requirement. And if they match, you are to write the matching factor down because that's the GCF between both sides. And then on the other side, the remaining factor is going to be the greatest common factors which were the outside values, and set those equal to 0. And now your trinomial has been fully factored. So now we are able to apply the zero product property that says to set each factor you found equal to 0 and solve for x, and those will be the solutions of your rational function. So I'm going to add 1 on both sides, and in this case my x is going to be a 1. I'm going to box that in as a possible answer. I need to add 1 on both sides. I end up with 5x equals to positive 1. Then I need to divide both sides by 5, divide by x to get my x by itself, and 1/5 is the other answer. So let's go back to my restricted values. Is 1 and 1/5 allowed? Well, my restricted values, scrolling back up here, were 0 and 6. 0 and 6 were the only ones not allowed. So these two values that I found are going to be acceptable values. And so since I used the blue upstairs on the previous problem, the ones with blue are the secured in already checked values, and we approve of those two, and we are done. And that's how you solve rational equations. I hope that helps. Thank you for practicing and pushing yourself. Reach out with any questions.